In last video, we saw the problems on work done, one of the problem on work done. So in this video, we will see some more problems on work done. Then we will move on to problems on potentials. So for next problem we will take up is the problem given is find the work done in moving a point charge of Q is equal to minus 20 microcoulomb from origin to point P along the path of x square which is equal to 8y. The path of movement is x square which is equal to 8y. Given electric field intensity is equal to 2 into x plus 4y into x cap plus 8x into ay cap volt per meter, and the epsilon is given as epsilon naught. So in this problem we have to find what is the work done when I move a charge from origin to point P. Now what is the coordinates of the origin? The coordinates of the origin is 0, 0, 0 in Cartesian coordinate system. So it is 0, 0, 0. So given charge is minus 20 microcoulomb, and the point P we have to move from B to P, that is 4, 2, 0, and the path of movement is x square which is equal to 8y. So we know that equation for work done, W is equal to minus Q integration from B to A E dot dl. So dl is equal to, what is dl in Cartesian coordinate system is dx into x cap plus dy into ay cap plus dz into a z cap. Now we know what is E, we know dl. So if you take dot product between E and dl, so E is equal to 2 into x plus 4y ax cap plus 8x ay cap dot dx into ax cap plus dy into ay cap plus dz into az cap. Now if you take dot product between these two, you will get E dot dl which is equal to 2 into x plus 4y dx plus 8x dy, because the dz az term in the E equation is 0. So the whatever az dot ax cap is 0 and az cap ay cap is 0, so you will get x and y term. But here if you observe these equations, and here in the difference integration with respect to the differentiation term is dx, and but term y term also present. Here also the differentiation term is with respect to y, but x term is present. What to do is here we have to replace this x or y with respect to other coordinates. If you want to replace y here, you can replace y with respect to x. Here also you have to replace dy with respect to x. So then you can apply integration limits. Here if I substitute this E dot dl in above equation, W equal to charge is given is minus 20 microcoulomb, 20 micro from B to P, 2x plus 8y into dx plus 8x dy. So given equation is x square which is equal to 8y. So from this equation I can write y is equal to x square by 8. So y is equal to x square by 8, and x can be written as root of 8 into root of y, root of 8 into root of y. So substituting in the place of y, I will substitute in the place of y, I will substitute x square by 8 in the place of y, I will substitute x square by 8. This will be, equation will be 2x by 2x plus 8 by 8 into x square into dx, and this will be in the place of x I will substitute root 8 into root y, root 8 into root y. So then I will integrate that, and I will get the equation as 20 into 10 to the power minus 6, 16 plus 64 by 3 plus 8 into root 8 into 2 by 3 into 2 to the power 3 by 2. So if you simplify this, the work done to transfer the charge from origin to point P, you will get as 1.6 millijoules. So this is the work done to move a charge from point B to point P, that is origin to point P is 1.6 millijoules. So next problem we will take one problem on spherical coordinate system. So given problem is find the work done in moving a point charge of Q is equal to 5 microcoulomb from origin to origin to point 2 meter pi by 4 pi by 2 in spherical coordinate system in the field given E is equal to 5 e to the power minus r by 4 ar cap plus 10 by r sin theta a phi cap volt per meter. Now this is the point. I have to transfer charge from 5 microcoulomb charge from origin to this point. So this is, I will take this as B and this is, I will take this as A. Okay. So I have to make what is the coordinates of origin? It is 0, 0, 0 and the coordinates of A is 2 pi by 4 and pi by 2. This is r, theta and phi. Now given electric field intensity is 5 e to the power minus r by 4 ar cap plus 10 r sin theta a phi cap. Here a theta components in electric field intensity is 0. So we know that equation for work done is minus q into integration b to a e dot dl. So we know that in spherical coordinate system, so in spherical coordinate system the elemental length dl vector form is given by dr into ar cap plus r d theta into a theta cap plus r sin theta d phi into a phi cap. So this is the expression for elemental length in spherical coordinate system. Now in the, if you substitute in the place of E dot dl, if you find the what is the dot product between E and dl, so you know that what is it? E is 10 by r sin theta, that is phi component in E, and phi into e to the power minus r by 4, that is r component in E. So substituting this in this equation, and if you obtain the dot product between E dot dl, you will get 10 by r sin theta into r sin theta d phi plus phi e to the power minus r by 4 into dr, which is equal to E dot dl, because theta component is 0, so there won't be a theta component in dot product, so you will get only phi and r component. So simplifying this r sin theta get cancels. You can write E dot dl, which is equal to 10 d phi plus phi e to the power minus r by 4 into dr. Theta component is 0 here because electric field intensity don't have any theta component in the given equation. So dot product also won't have theta component. Now you know that the integration W is given as minus q integration of E dot dl. What is E dot dl? E dot dl is phi e to the power minus 4 minus r by 4 into dr plus 10 d phi plus theta component is 0. So the integration limit will be, the for r will be, it is from, if you see the limit, the coordinates, it is from 0 to 2 pi by 4 pi by 2. So r limit is from 0 to 2, and the phi limit, what is the limits for phi? It is 0 to pi by 2. It is 0 to pi by 2 is the phi limit, and theta limit is 0 to pi by 4. But theta term is 0, so no need to consider that. So we have only two integration terms. Now if you integrate this, you will get, that is q minus 5 into the power minus 6 phi e to the power minus r by 4 divided by minus 1 by 4 limit from 0 to 2 plus 10 into phi 0 to pi by 2. Now if you simply apply limit and simplify this, you will get minus 5 into the power minus 6 into minus 20 to the power minus 0.5 plus 20 to the power 0 plus 10 pi by 2, which is equal to, if you simplify, you will get work done to move a charge from the origin to point P is minus 117.886 microjoules. So this is the work done to move a charge from point origin to point P or point A. So in next video, we will see problems on potential and potential gradients. Thank you.